Before studying the arithmetic series, I want to make quick revision about the arithmetic sequence. You know the arithmetic sequence, like the sequence we have 5, 7, 9, 11, 13, 9 to 9. Each time we add 2 to get the next term. And you know that Tn is equal to A is the first term, plus n minus 1 multiplied by d is the common difference. And the common difference here, 7 minus 5 is 2. So write Cn as 5, a is 5, and plus n minus 1 multiplied by 2. Multiply 2 by n, it's 2n, and 2 by minus 1, it's minus 2. So we'll end up with 2n plus 3. And we can find Tn directly. Just look here. Each time we add 2, we add 2. So write 2n directly, right? 2n. Then compare this to here and the first term. What shall we do to add? What shall we do from to add 2 to get 5? We have to add 3 because 2 plus 3 equals 5. So Tn is 2n plus 3. And from this rule, this is the nth term, we can find T50. T50, it's a 2 times 50 plus 1. We can find T90. T90, it's a 2 times 90 plus 3. That's it. And if you want to find T5, T5 in general, it's A plus 4D because it's n minus 1 multiplied by D. Okay? I'm talking in general. So Tn is A plus n minus 1 multiplied by D. What if I want to find the sum of all these terms? So to find the sum of terms, it's Sn. Sn means the sum of all terms of the arithmetic sequence. The sum of all terms of the arithmetic sequence. So how can we find Sn? Before studying Sn, and how can we find the sum of the arithmetic sequence, the sum of all terms, we should know what is L. L is the last term, and the last term, we deal with it as any term. It's A plus n minus 1 multiplied by D. But n in this case is the number of terms, the number of all terms. Okay? So how can we find Sn? You know, any sequence is written in this form: A, that is the first term, then A plus D, then A plus 2D, then A plus 3D, till the last term. The last term is L. And the term before L is L minus D. And the term before L minus D is L minus 2D and L minus 3D. And the number of terms is N. So we will write N terms. Okay. What is Sn? Sn is the sum of all terms. So write A plus D plus A plus 2D plus till the last term is L. And the sum before it, it's L minus D and L minus 2D. And we can write the sequence, the sum of all terms from the end to the first term. So the last term is L. So we can write it as L and L minus D and L minus 2D. I wrote the last term at the first. And here we have at the end, we have A, and we have here A plus D, and we have here A plus 2D. So that is equation 1, and that is equation 2. We can add them. So Sn plus Sn is equal to 2Sn. That is the left-hand side is 2Sn is equal to. Add A to L. It will be A plus L. And add A plus D to L minus D. D and minus D cancel, so it will be plus A plus L again. And here we have A plus 2D, and here L minus 2D. 2D and minus 2D, one cancel another out, so it's A plus L. Plus here, and we have here L minus 2D and A plus 2D, cancel them out, so it will be A plus L. And also here we have L minus D and A plus D, it will be A plus L. And here we have here at the end A plus L. So we have A plus L multiplied by n terms. So 2Sn is equal to what? The number of terms of the sequence n multiplied by A plus L. Then divide both sides by 2. You will end up with Sn, the sum of all terms, is equal to what? N over 2 multiplied by A plus L. You know what is A? A is the first term and L is the last term. So Sn, the sum of all terms, is equal to N over 2 multiplied by A plus L. Okay. And L is equal to what? A plus N minus 1 multiplied by D. So we can write, instead of that, we can write N over 2 and multiplied by here A plus. We will write instead of L, A plus N minus 1 multiplied by D. So Sn equals N over 2. And here A plus A is 2A plus N minus 1 multiplied by D. So we have two rules to find the sum of all terms. Sn, the sum of all terms of the arithmetic sequence, is N over 2. N is the number of terms divided by 2 multiplied by A plus L. Or we can use this rule as N over 2 multiplied by 2A plus N minus 1 multiplied by D. That's it. I'll show you now an important information, S5 minus S4. What is S5? S5 is the sum of the first 5 terms. It's T1 plus T2 plus T3 plus T4 plus T5 minus S4. You know what is S4? It's a T1 and T2, T3, T4. So T1 and minus T1 cancelled, T2 and T minus T2 minus T3 and T3, T4 and minus T4. So we'll end up with T5. So S5 minus S4, the sum of the first 5 terms minus the sum of the first 4 terms equals T5, the 5th term. So S10 minus S9 equals T10. S10 minus S9 equals T10. S13 minus S12 equals T13. If the sum of terms of a sequence is positive, that means Sn is greater than 0. And if the sum is negative, that means Sn is less than 0. Here in this example, I want to get the sum of the terms of the arithmetic sequence 13, 22, 31. So each time we add 9. So the common difference is 22 minus 13 is equal to 9. And A equals 13 and L equals 139. So we can find the number of terms if we use this rule. L, the last term, is equal to A plus N minus 1 multiplied by D. So 139 equals 9 plus N minus 1. So I want to get N multiplied by D, which is 9. A is 13. A is 13, right here 13. And plus N minus 1 multiplied by 9. So 139 equals 13 plus 9 times n is 9n, and 9 times negative 1 is negative 9. So 139 equals 9n, and 13 minus 9 equals 4. Move 4 to the next side. 139 minus 4 equals 9n. So 9n equals 139. 35. Okay. So here, 135, it will be divided by 9. So n equals 135 divided by 9 equals 15. Now we can find the sum of all terms because we have 15 terms. So Sn equals n over 2, 15 divided by 2, multiplied by a plus l, 13 plus 139. That's a and that's l. So it will be 1140. Let's go to the next example. Find the sum of the 10 times of the arithmetic sequence starting from T8. You know, Sn is equal to what? N over 2 multiplied by a plus l. Or we can say Sn, it's n over 2 multiplied by a plus l, we can write instead of la plus n minus 1 multiplied by d. So Sn equals n over 2 multiplied by 2a plus n minus 1 multiplied by d. And here we will use the second rule. But we want to find the sum of the 10 terms starting from T8. So here, the first term is T8. So S10, we need to find sum. We need to find the sum of the 10 terms of the 10 terms. So S10 is 10 over 2 multiplied by T2 multiplied by T8 plus n minus 1. You know, n, it's 10. So plus n minus 1, 9 multiplied by d. So let's check the sequence again. D equals 7 minus 3 equals 4. And we need to find T8. T8 is a plus 7d. So a is 3 plus 7 multiplied by 4. So it's 3 plus 28 equals what? 31. So here, S10 equals 10 over 2 multiplied by 2 multiplied by 31 plus 9 multiplied by d. The difference, the common difference here is 4. So we can use the calculator directly to get the sum. 10 over 2, 5, and 2 times 31, 61, 62 plus 36. You will end up with 490. How can we find the sum of integers included between 10 and 100 that are not divisible by 7? You know, the integers included between 10 and 100, it's 11, 12, 13, 14, 15 till 99. They are all integers between 10 and 100. We can find Sn here. So A here is 11, and L equals 99, and D equals 1. And L is equal to A plus n minus 1 multiplied by D. So 99 is equal to 11 plus n minus 1 multiplied by D. D is 1. So 99 equals 11 plus n minus 1. So it's a 10 plus n. Move 10 to the next side. So n equals 99 minus 10. It's 89. So Sn here is 89. Is 89 over 2 multiplied by a plus l, 11 plus 99. So S89 is equal to 89 over 2 multiplied by 110. Then it will be equal to 89 over 2 multiplied by 110 divided by 255, 55. So it will be 4,895. Then we want to find the sequence of integers between 10 and 100 which are divisible by 7. All terms are divisible by 7. So the first term after 10 divisible by 7 is 14, then 21, then the last term before 100, which is divisible by 7, it's 98. 98 is divisible by 7. So here we have A equals 14, L equals 98, and D equals 7. And you know that L is equal to what? L is equal to A plus N minus 1 multiplied by D. So 98 equals 14 plus N minus 1 multiplied by 7. So 98 equals 14, and 7 times N is 7N minus 7. 14 minus 7 equals 7. Move it to the next side. It will be 98 equals 7 plus 7N. Okay. Then move 7 to the next side. Will be 98 minus 7 equals 7N. So 9 to 1 equals 7N divided by 7. So N equals 1 and 3. So it will be 13. So we need to find the sum of these 13 terms. So we'll find S13 equals what? 13 over 2 multiplied N over 2, A plus L. A is 14 plus L is 98. So S13 equals 728. Now we have the sum of all integers from 10 to 100, K, 11, 12, to 99. And then we have the sum of all integers, which are divisible by 7, starting from 14, 21, and ending in 98. We have S here and S here. Subtracting them, if we subtract them, you will get the sum of all integers which are not divisible by 7. So the sum of the integers included between 10 and 100, which are not divisible by 7, equals 4,895 minus 728 equals 4,167. That's it. Find the arithmetic sequence in which T1 is 12 and Tn equals 78. What is the meaning of Tn? Because we are given that Sn equals 1035. You know what is Sn? The sum of n terms. The sum of n terms of the sequence starting from T1. And Tn, we deal with Tn here in this case as L. So we have A as 12 and we have L as 78. And Sn equals 1035. So L equals A plus N minus 1 multiplied by D. As you know, L is equal to A plus N minus 1 multiplied by D. But we don't have D, we have L, we have A. And we don't know what is N. N is the number of terms. So leave this rule now. And we know that Sn equals N over 2 multiplied by A plus L. We know Sn. Sn is 1035 equals N over 2 multiplied by A is 12 plus L is 78. So 1035 equals N over 2 multiplied by 12 by 7 plus 78, it's 90. Simplify, it will be 45. So 1035 equals 45N. Divided by 45, so N equals 1035 divided by 45, N equals 23. By using the calculator, we'll get 23. So we have here, we have A, we have L, we have S23, we have S23. because n is 23. N equals 23. Now we can find the last term. The last term, which is Tn 78. So T23, and T23 is equal to 78, and T23 is A plus 22D equals 78. A is given as 12 plus 22D equals 78. So 22D equals 78 minus 12. 78 minus 12. So 22D equals 78 minus 12, 7 minus 1, 6, and 8 minus 2, 6, divided by 22, so D equals 3. Now we have D. So we can form the sequence. The first term is 12, and D is 3. The second term will be 15, and the third term it will be 18 till 78. That is the sequence. Find the least number of terms that should be taken from the arithmetic sequence 22, 25, 22, 19, starting from the first term to make the sum negative. So A is 25, the first term is 25, and D 22 minus 25 is negative 3. And to get the least number of terms that should be taken to make the sum negative. So in this case, we have tried Sn less than 0 because the sum is negative. Sn is less than 0. So n over 2 multiplied by 2a plus n minus 1 multiplied by d is less than 0. We can multiply both sides by 2 over n here and 2 over n here. Cancel them out, so 2a plus n minus 1 multiplied by d less than 0. 2a. So 2 multiplied by 25 plus n minus 1 multiplied by d is negative 3 multiplied by negative 3 less than 0. So 50. And negative 3 multiplied by n is negative 3n, and negative 3 multiplied by negative 1 is 3 less than 0. So negative 3n less than negative 53. Divided by negative 3, and it changed the direction of the inequality. So n, I divided by negative 3. So n is greater than 17 and 2/3. So what is the term which is greater than 17 and 2/3? It's 18th term. So n in this case equals 18. So the least number of terms that should be taken starting from the first term to make the sum negative is 18 terms. So we need to get S18, and S18 is going to be what? It's 18 over 2 multiplied by 2a, 2 times 25, okay, plus n minus 1, 18 minus 1, it's 17, multiplied by negative 3. D is negative 3, okay? So you need to get the sum of 18 terms. 18 over 2 is 9, and here it's 50 minus 51. 50 minus 51 is negative 1, multiplied by 9. 9 times negative 1 equals negative 9. That's it.